Good morning, guys. So today is the 27th of March, and you guys are in the middle of doing the 2019 paper one. So no one has gotten on to me and asked me to do any particular questions. So what I think might be useful to kind of let you do the questions yourself. I think that's the best way to do this, is to do the question yourself. But maybe I might just go through the paper now and we might just read through it, and I might give you hints and maybe tips about how to do particular questions. Okay, so that's what's going to happen now. So I won't be doing the actual questions, but I might be suggesting strategies or ways that I might tackle it, but letting you guys actually do the maths, if that makes sense. Again, if you need me to do specific questions, guys, let me know. Okay. Yeah, it's like I'm talking to an empty room here sometimes. Okay, but please do let me know. Yeah, I know this is a tough situation, but we'll try and do our best for you. Mathematics paper one, ordinary level. So maybe if I go into present mode. So ordinary level, that's for most of you guys. Friday, June the 7th, afternoon 2 to 4:30. So that's kind of important. That paper one, lads, tends to happen on Friday. Now we don't know what's going to happen this year. I'd imagine nothing has said it's going to change yet, but if the current format is going to stick, it's going to be Friday for paper one, and then on the Monday you will have paper two. So you'll have paper two. You'll have the weekend to kind of swat up on the paper two stuff. So you need to. That's kind of something that you need to be aware of. Okay. Instructions. Let's get straight into the maths here. Okay, so question one here, we would expect this to be a kind of a fine, easy warm-up question. Do you know what, guys? I'm going to write on this, and I'm going to try and put this thing up on Edmodo. Okay, so I won't write solutions, but I'll write kind of hints and things on this script, and then that'll go up on Edmodo as well for you. So you're going to have this commentary that I'm speaking my way through it, and you're also going to be able to look at the visual thing as well. So maybe pay attention to what I'm saying, and I'll try and get this up as a PDF for you on Edmodo as well. Okay, so Emer, back in present mode, Emer earns a gross wage of 40,000 per annum with company A. Emer pays income tax at a rate of 20% on income up to the standard rate cut-off point of 35,300. She pays tax at a rate of 40,000 or 40% on the remainder. She has annual tax credits of that amount of money. Find how much income tax she pays per annum. Okay, so what we have to do is we have to think about this, that we have a chunk of money as our income, and that's the 40,000. And that's broken up into two sections. This section down here, which is 35,300, and this section up here, which is 40,000 minus 35,300. And this part up here, that's taxed at 40%. And this part down here, that's taxed at 20%. And then to find total tax, well, what do you think we would do to these two values? Yeah, to find the total tax she could end up paying, we'll go in here, and then I think we call that the gross tax. But that's not the amount of tax she ends up paying, because that amount gets reduced. Okay, so that should get you flying on question one. Emer pays her health insurance, which costs 1,500 net, which costs her €1,500 net. Find her annual income after paying income tax and health insurance. Okay, so the answer to this thing here, let's say the answer to this was, I don't know, answer ANS. Well then, obviously the amount of money that's going to go out in this section down here will be ANS plus 1,500. So that's what she has to pay out. So this question here is really asking, what does she get to keep after paying income tax and health insurance? What does she get to keep? Okay, so that's question one. Part C now. Sorry, I thought that was question one. That's not. On to part C. Emer is planning to change jobs. She is offered a job by company B with a gross wage of 38,000 and a bonus of 15,000 tax-free to Emer, to be paid by the company, which she would use to pay her health insurance. Her tax rates and credits would remain the same. Find by how much Emer's net annual income will increase if she accepts the job at company B. So 38,000 and a bonus of 1,500 to be paid by the company, which she would use to pay her health insurance. Her tax rates and credits would remain the same. Find by how much Emer's net annual income after paying income tax and health insurance will increase if she accepts the job at company B. Okay, so the setup for this one is that there's going to be 38,000. And just like up here, when I had a kind of a bar representing the 40,000, yeah. Okay, so the setup for this one is there's 38,000 and that's now in the bar. That's now in the big huge bar. And we were going to break that into two sections. And this point here, the standard rate cutoff, that's still the same value as up above. What was it, 33,000 or something? 35,300. So that's 35,300. So it's 35,300 in here. So there's going to be what, I don't know, 4,700 or something up here. And that's again taxed at 40%. That's taxed at 20%. And you worked out the total gross tax. So what do you think you're going to do to these two answers to get the gross tax? That's the big amount of tax. She won't end up paying that because she has tax credits. So that will reduce that value. And then this thing here, this 1,500, well, she's going to have to, at that stage, the company will give it to her. And the moment the company give it to her, she's going to give it to her health insurance provider. So really, she doesn't really see that. So we can kind of ignore that in this question. So you're going to be comparing this answer to this answer to answer the question. Find by how much. So you're going to compare this answer here, ANS1 and ANS2. I think that's actually ANS3, but anyway. So you're going to go ANS1 minus ANS2 to compare the two different answers. Okay, so that has to be question one done. Question one done. Okay, on to complex numbers. Guys, complex numbers, almost a guaranteed question. Study it, study it, study it, okay? The complex number z1 is equal to 2 plus I, where I squared is equal to -1, as shown in the Argand diagram below. Nothing weird there. We know what an Argand diagram is. Okay, the complex number z1 equals 2 plus I. Now there's a diagram given, so we check to see if this information is on our diagram. And look at that, it's 2 plus 1I, there it is there, 2 plus 1I. So this thing here is the same as this thing here, okay? Now, first question. Z2 is equal to 2Z1. Find the value of Z2. Okay, well, it's going to be twice as big as this guy here because it's 2Z1. 2Z1. So if that's Z1, Z2 will be twice as big as that. So what's twice as big as 2? What's twice as big as 1I? Okay, this line up here, can you remember what that means? This line on top of the on top of Z1. What does that mean again? Okay, conjugate is the complex conjugate of Z1. Complex conjugate. Write down the value of Z1 with a bar on top of it. That's the complex conjugate. How do you turn this complex number here into its complex conjugate? You have to do something to this. So look that up in your notes if you don't know. You should know it already, guys. Okay, investigate if Z2, so you've worked out what Z2 is here. So let's say, I don't know where it is, but let's say it's down here. In fact, it's not going to be down here, but let's imagine it is. Let's call this Z4. I don't think we don't go up as far as Z4. So let's say Z4 is there, and we're asked to find Z4, the modulus of Z4. So we're asked to find the modulus. These things here suggest modulus. Can you remember what those vertical lines mean again? What does it mean? Those vertical lines. Yeah, it means the distance. It means the distance from that point, which is 4, minus 3. The distance from that point to the origin 0, 0. that distance there. So you're going to have to work out the distance Z2 is from the origin. You're going to have to work out this sum here, Z1 plus the conjugate of Z1, and then find its distance from the origin. Okay, and you want to check if they are equal. I don't know if they will be or not. Okay, so guys, complex numbers, it's almost a guaranteed question. We can't say it's a guaranteed question anymore, but every year it seems to come up, okay? They like examining it, and it's really simple stuff, okay? Yeah, swat up on complex numbers. So we're still not out of question 2. Show that Z1 is equal to 2 plus I as a solution to the equation Z squared minus 4Z plus 5 is equal to 0. Okay, so now this is probably something we haven't really covered in class. Kind of algebra with it, okay? Solution. So this question will fall apart when it comes to solution. If I have an equation, let's say 4x plus 3 is equal to 15, okay? So 4x plus 3 is equal to 15. And then I can do my usual sums on this. I can go 4x is equal to 15 minus 3. I can go 4x is equal to 12. I can go x is equal to 12 over 4. X is equal to 3. So we would call this thing here a solution. So this is a solution to this equation. Sorry, you can't see me pointing. This is a solution to this equation. Now, because this is a solution to this equation, what that means is that we can put this thing here in for x and it should work out for us. So we can verify our answer. So we can now go 4 bracket 3, this 3 here, plus 3 is equal to 15. And we want to check if that's true or not. 4 3s are 12, plus 3 is 15. So 15 is equal to 15, true. So when it's a solution, we can put it back in for the variable. So the variable is up here and it's here. So you're going to turn those into what you're checking for. So you're going to put 2 plus I in wherever there's a z. And you'll need to figure out how to square something. Okay, so you'll need to figure out how to square something. How to square a complex number. What does squaring mean again? Squaring. If I square 6, I get 36. So what did I do to the 6 to get 36? Okay. Right, on to question 3. The function f is defined as f of x is equal to minus x cubed plus 4x squared plus x minus 2, where x is an element of OR. Complete the table below for the values of f in the domain minus 1 to 4, and hence draw the graph of the function fx in the domain minus 1, x is an element of OR. Okay, so we have our function up here, and we have to put the outputs into this table here. So we covered this loads over the past week. You put that into your calculator, right? You go into the table format and you put that into the table format. You put in these values and you're going to get out the values there. Yeah. Without even going on to part B, I'm going to guess that we'll be asked to draw the graph. There we are. Draw the graph of the function. There it is there. So you'll get some numbers out here and you'll draw a graph of the function. You should be well able to do that. Use your graph to estimate the 2 roots of f of x, which are in the domain minus 1. So roots. Roots. What do roots mean again? Where a function crosses x-axis. Okay, so that's what that question there is examining. Roots where a function crosses the x-axis. Find the value of x for which f prime prime of x equals 0 and where f prime prime x is the second derivative of f of x. Okay, so I might just nab this. How do I do this again? Can I take a picture? Let's grab it there and let's plonk it in here. Yeah. So f of x is this guy here, and we're asked for f prime prime of x. Now we know what f prime of x is. We differentiate this guy. So when we differentiate this, we'll get some stuff. I'll differentiate the minus 2 for you. That'll turn into a plus 0. Yeah. But when we when we find f prime prime of x, we're differentiating this thing here. So we're differentiating the thing that was differentiated. Sorry, we're differentiating the answer of the previous differentiating. It's the second derivative. So we differentiate and then we differentiate again. That's all that is. Okay, question 4. Just looking at the time there, gentlemen, I might just do section A today, if that makes sense. And if you want me to do any questions in section B, you can let me know over the weekend, and I'll try and get them up before Monday for you. It's just, this is going to take me forever. I didn't realize I didn't realize how slow I would be at doing this. Okay, so we're on question 4 now. 3x plus 1 over 5. Okay, so probably the handiest thing to do here would be to do something that's going to turn this guy, and this guy all into the same number. So what number do 5, 2, and 10 all divide into? And that's the number you're going to turn these into. And whatever we multiply the bottom by, we must also multiply the top by exactly the same thing. So that should get you flying on question 4. Solve the simultaneous equation. So there's 2 types of simultaneous equation, easy or hard. And easy we match up. Hard we isolate plus substitute. So you need to make a decision. Is this thing here an easy type, or is it the hard type of quadratic equation? Hint. Okay, so is it easy or is it hard? If it's the hard, you've got to isolate and substitute. Okay. Question 5. Okay, so we haven't looked at this yet. So that's stuff that we haven't done. So that's a problem. Okay, so we're going to come across this as we close out the course, stuff that we haven't done. And I don't want to spend any more time kind of teaching topics. I want to get into revising for the final exam. So as we come across this sort of stuff in the papers, we'll knock it off, okay? So do you know what I'm going to do? I'm going to get a video up maybe tomorrow night. So you'll have this video for Saturday morning if you're doing study over the weekend on how to answer question 5, the trapezoidal rule. So I'll get a video up on using the trapezoidal rule. Video on using trapezoidal rule to follow. Okay. Yeah, there's nothing really to it. It's just a formula that you need to be able to use. The formula is in the log tables. Okay, so you can skip question 5, or have a go at it if you want. If you want to find the equation in the, or if you want to find the formula in the log tables, please have a bash at it. Nuala can walk at a speed of 1.6 meters per second. 1.6 meters per second. Write the speed in kilometers per hour. Okay, so I suppose the way I tackle this is, I think, I'm either going to have to divide or multiply. Yeah, so probably the handiest thing to do is to turn 1.6 meters per second. First of all, go into 1.6 meters per minute, and then 1.6, sorry, no, that's wrong. And it's not going to be 1.6 meters per second, sorry, 1.6 meters per minute, sorry about that. Go meters per minute first. So would you expect to do, if she's walking at 1.6 meters per second, would you expect her to do less or more than 1.6 meters per minute? Yeah, so if she's doing 1.6 meters every second, we would nearly expect it to be 60 times 1.6, right? Yeah, meters per minute. And then you can turn into meters per hour. Okay, and then you're in meters per hour. And then how will you, so for every 1,000 meters, it's going to be a kilometre. So you turn this number here into kilometres. So I suppose it's step by step by step, you know. And each time think about, do you want to get more or less? And if it's more, you're multiplying. If it's less, you're dividing. Okay. Solve the following inequality. Okay, so let's multiply this thing out. Actually, I'm not going to multiply it out for you. This bracket here, guys, you need to know that means multiply. You all know that means multiply at this stage. So you get something here. You then treat this thing. Remember, we treat this just like an equal sign. Okay, and we do all our algebra with it. And that will give us an answer. Okay, and let's say the answer happens to be, I don't know what the answer will be. Let's say x is less than, I don't know, minus 2 or something. Yeah, x is less than minus 2. Okay, if it's x is an element of or, well, that's the real number, so that's every single number down here. If it had have been, let's say x is less than 2 and its x is an element of z, well, then we would only shade in these guys here. And we wouldn't shade in the 2. We would leave him empty. Okay. So have a go at that question. We didn't spend much time on these when we were doing them. We would have done this before Christmas last year. So they're probably a distant memory. I haven't really looked at them since then. Yeah. Have a go at it anyway. See what happens. Question 6. I'll put up, if you're stuck with it, let me know. Anyway, yeah, see what happens. Okay, question 6, this thing here. Ooh, look at that. That's a tough question. 2 to the power of 2x minus 1 equals 64. So I'm going to do this question because I don't think any of you will kind of know what to do here, to be honest with you, okay? Look, you know, just, well, that's a bit mean. If you don't want to listen to it, you know, skip ahead a few seconds. But this is the way to tackle this question, okay? This 64 here, we're going to write that as 2 to the power of something. So what do I have to raise 2 by to get to the power of 64? So it's 2, multiplied by 2 is 4, multiplied by 2 is 8, multiplied by 2 is 16, multiplied by 2 is 32, multiplied by 2 is 64. So that's 2 to the power of 2 there. This is 2 to the power of 3, this is 2 to the power of 4, this is 2 to the power of 5, and this is 2 to the power of 6. So 2 to the power of 6 goes up here. Now, this box here must be the same as this box here. So my next leap in logic will be 2x minus 1 must equal 6. Okay, so that's kind of like a trick almost. We have to turn that 64 into 2 to the power of something. Okay. And that's section B then. Okay, so I'm going to leave it there. Yeah, so I'm going to leave it there. So I have a little bit of teaching to do over the weekend on question 5. Yeah, good. So I'm going to try and get that up for you. So that's the entire section A. Kind of I talked about it. Yeah, we need to do well on section A. Yeah, section A is where you will kind of get your pass, you know. You'll get a good grade with the section B's, but if you do well on section A, you should be getting a pass, you know. That's really kind of the straightforward. There's no storytelling in section A. It's really straightforward questions. So let's take a look at what I mean by straightforward question. This, for example, there's no talking about, you know, Johnny and Mary have apples and oranges or anything like that. It's just straightforward maths, okay? So that's what we need to be getting good at. Like this type of stuff seems to come up every year, right? Fill this in, draw a function, you know? Okay, I'll get rid of that because that'll just confuse people. Okay, so I'm going to leave it there. have a good weekend. So finish off the 2019 paper 1, and then I'll put up a bit of teaching on this trapezoidal rule, and then on Monday, if you're done with this, I will be assigning you to have a go at paper 2 2019. Okay, so that's the plan for the next few days. So I'll see you again on Monday. Enjoy the weekend.